Hello students, today we are discussing about electric dipole. So electric dipole moment. So electric dipole is what? It's a system of a system of uh, equal charges, equal and unlike charges, equal and unlike charges separated by, so they are separated by a fixed distance, separated by a fixed distance. So this is called electric dipole. It's a electric dipole. Now this electric dipole is denoted by the letter is what? It's a P, electric dipole. So if I choose about, this is negative charge minus q, and minus q, next one is plus q, separated by distance is what? It's a d. This is d. D, it's what? Okay, 2a. We can also say it's a 2a. So this is what? It's a 2a. So is the center, like from here to here, this is what? A and a. Yes. So if I choose as this is as a system, I'm taking as a system. Okay. So this system is called dipole. It's a electric dipole. Electric dipole. So dipole is, it's a P, we can say, and dipole is a vector quantity. It's a vector quantity. A vector quantity means the charge, it should be negative and positive. Dipole moment is directed from negative to positive, negative side to positive side. Okay. So next one, dipole P bar is equals to 2a into q. That 2a we can also say d into q. So is what? Electric dipole. Okay. So next concept is what? Electric dipole is placed in uniform electric field. It is pivoted. Pivoted means it is just placed on the screw or freely suspended in external electric field, external uniform electric field. Okay. So when, next one, first one I'm talking about, when an electric dipole is suspended or placed. Okay. So that's what? Placed in a uniform electric field. It's a uniform electric field. So for the uniform electric field, just you choose about, this is the uniform electric field, like this we can take it as. So from this we can talk about, one is what will be the net force and what will be the interaction energy. Okay. So and what is the torque, net torque also we can find on this. So here it's a electric field is E bar. Yes. So dipole is suspended. This is dipole. It's what? Suspended, like this is the point, right? So it's what? O. This is what? A and A. So it's a minus q. Next one is what? It's a plus q. When positive charge is placed in external electric field, the force acts in the direction of electric field. F is equals to EQ. So negative charge means what? F is equals to minus EQ in opposite direction. Yes. So now here, first one I'm talking about this. What is the net force? What is the net force? Okay. So just one net force, F is equals to, okay. So this is what? F is equals to F due to positive charge, due to negative charge. Due to positive charge is EQ, due to negative charge is minus EQ. Net force is what? 0 is the net force. So net force is okay, fine. But the thing is about here, we are talking about two positions. One is plus q and next one is about minus q. one is plus q and next one is the minus q. Okay, so here these two forces are not acting along with the same line, they are acting at different lines. This is what, this is one line of action of force, this is another line of action of force. Okay, so I can say this is what, it's a line of action, this is line of action of force. Okay, so this, so first these two are here. Yes, there are two different points of a body, means what, this is a small short dipole, so acting the forces means what you say, it produces torque. Okay, that is what torque, torque is, it's a tau, so torque is also called, is called what you say, it's a movement of couple. Okay, movement of couple, it's a c, movement of couple. Okay, so this torque tau is equals to, torque is equals to, or couple is equals to, I can say, force into the distance between these lines. Okay, distance, distance between the lines, which lines are these, so which lines, the lines of action of force. Okay, so now we can talk on this, it makes an angle theta, this is perpendicular distance, so it's what, total is what, it's a 2a, this will be what, 2a sine theta. Okay, so is what, perpendicular distance is what, 2a sine theta, the distance between these two lines is what, it's a 2a sine theta. So torque tau is equals to, force means what, e into q into 2a sine theta. So this is torque tau is equals to, so this E, next one it's a P sine theta. So then what? Tau is equals to PE sine theta. Vectorially if you write, tau bar is equals to P bar cross E bar. Okay. So this is what? It's a torque acting on this. Now torque is maximum, means whenever theta is equals to 90 degrees, tau become as what, maximum, that maximum is what you say, it's a PE, P means what, 2a into, it's what, q, E means what, electric field we can say. So this is, from this you got it understand from here. So whenever dipole is suspended or pivoted in a uniform electric field, so the net force is what, 0, net torque tau is equals to PE sine theta, that's what, P bar cross E bar. Okay, sir, if this, yeah, when it is suspended in non-uniform electric field, what happens? So non-uniform electric field, just I'm giving as this, it's a note for this is, in the non-uniform electric field, non-uniform, okay, electric field. So in the non-uniform electric field, F net is equals to, not is equals to 0, tau also not is equals to 0. Okay, so then tau is, if you are talking about the net torque, sir, F net is not is equals to 0, means what, E1 Q1 plus E2 Q, that's what, EQ plus EQ, like different directions we can talk on this. But torque tau net is equals to, if you calculate, the value is nearer to this one only. So that's what I'm trying to say. Yeah, when a dipole is suspended in a uniform electric field, net force is 0, net torque is, that's what, PE sine theta, and when it is suspended in non-uniform electric field, net force and net torque both are not is equal to 0. Interaction energy of electric dipole in electric field. So first, electric field, uniform electric field I am considering. This is uniform electric field. Okay. Electric dipole is suspended, like this is the electric dipole. Here is electric dipole. This is as we discussed in earlier, it's a minus q, and next one is what? Plus q. Electric field is E bar. So this distance is d, otherwise it's a 2a, also we can write it as this. So this is interaction energy. Interaction energy is what? It's a potential energy. Potential energy, electric potential energy. Potential energy. So potential energy U is equals to V into Q. We know from our previous sessions. U is equals to V into Q. V stands for electric potential, Q is the charge. Now from this given situation, you can observe. So just I'm taking as this is what uniform electric field, and these points, this is what equipotential point, this one also equipotential point. So in equipotential, this is what? It's a V1 potential. Next one is V2. V1 and V2. At every point on this line, a potential is what? Same. This is V2 everywhere. This is V1 everywhere. You know one thing. So this is in equipotential surfaces. When we are moving in the direction of electric field, potential gradually decreases. So potential decreases. So this is means when we move in the direction of electric field. Okay, electric field. So potential decreases. Potential decreases in a uniform electric field. Uniform electric field. So when potential decreases, you know this is what? E is equals to minus delta V by delta X is the relation between these two. Negative sign indicates what? As we move in the direction of electric field, the potential decreases. It's what? V1 and V2. V2 is smaller than of V1. Its potential energy, this is what? U1 is equals to V1 into Q. See? U1 is equals to V1 into minus Q, and U2 is equals to V2 into, it's a plus Q. So the total interaction energy is equals to interaction energy U. Okay, U is equals to U1 plus U2. U is equals to U1 means what? V1 into minus Q plus V2 into its a Q. This U is equals to V2 minus V1 times of its a Q. U is equals to delta V times of U. Now we can go on this. This delta V is equals to what? Minus E into delta X. What is delta X? The delta X is what? The distance between from here to here. This is what delta X. It's a delta X which is known as, I'm taking as, it's a D. Okay. What is D? Now this makes an angle theta. This, it is what? Theta. So this is what? 2A. So will become as, just I'm saying as it's a D. This become as what? D sine theta. Next one is what? D cos theta. So distance between these two charges is D cos theta. U is equals to delta V means what? E into delta X into Q. Okay. So what is delta X from this? Delta X is equals to, from here, this is what? D cos theta. Delta X means what? It's a D cos theta. This is the distance. Now U is equals to minus E t cos theta into q. U is equals to minus E t into q means what? It's a p dipole moment. It's a cos theta. This is what U is equals to minus p bar dot E bar. So vectorially, it's a scalar product. So negative p bar dot E bar. Otherwise, minus pe cos theta. Next one, work done in changing orientation of dipole in electric field. So orientation of dipole in electric field, just imagine that electric dipole is suspended or pivoted on a screw in a uniform electric field. Just you say, as a theta 1 is angle made by electric dipole with the field, and theta 2 is the angle made by electric dipole with the field. So just what I'm trying to say, from theta 1 to theta 2, to rotate that, to change the angle from theta 1 to theta 2, what is the external work is done. So that is called, what is say, work done in changing an electric orientation of the dipole in a uniform electric field. Okay, so just I'm talking about for the first one, if theta 1 is, if theta 1 is angle made, angle made by electric dipole, angle made by electric dipole, dipole in a uh, with a uniform field. Okay, electric dipole, angle made by electric dipole with electric field, with electric field. Okay, is this. And so this is what the potential energy U1 is equals to minus PE cos theta 1 is my first condition. And the same thing, if so I want to rotate this electric dipole from theta 1 to theta 2. Okay, if theta 2 is angle made, angle made by an electric dipole, electric dipole with the electric field. So U2 is equals to minus PE cos theta 2 is the second condition. Now uh, for conservative fields, for conservative fields, so for the conservative fields, what happened? The work done by external work done. Okay, the work done is equals to change in its potential energy. W is equals to, so minus PE cos theta 2 minus of minus PE cos theta 1. So this W is equals to, so minus PE cos theta 2 plus PE cos theta 1. So this is what W is equals to PE times of cos theta 1 minus cos theta 2 is the work done while changing its orientation from theta 1 to theta 2. And one thing you need to remember, when it is electric dipole is in uniform electric, it is in stable position. Okay, for stable position, whenever stable condition is mentioned, theta 1 is equals to, theta is equals to what? 0. Unstable, okay, unstable condition is given, theta is equals to what? 180 degrees, completely rotated. Okay, so this theta is equals to 180 degrees for the unstable. So if you use for this, this is what for the stable to unstable. So theta 1 is equals to, I'm taking as theta 1 is equals to 0 degrees and theta 2 is equals to 180. Okay, so do you know this cos 180 is what? Minus 1. Now W is equals to PE times of cos 0 degrees minus cos 180 80 degrees. So this W is equals to PE times of cos 0 is 1 minus of minus 1. So will become as what? 2 PE. Direct answer for this. Okay. So this W is equals to the work done externally, okay, to change from theta 1 to theta 2. W is equals to PE times of cos theta 1 minus cos theta 2. Here we are discussing about force on dipole in non-uniform electric field. So when a dipole is pivoted on a uniform electric field, net force is 0, but net torque is what? Tau is equals to P bar. So cross P bar cross E bar, that's what PE sine theta. So if it is suspended in non-uniform electric field, net force is not 0. So net force is not 0 means what is the force? Okay. So first one is that when dipole is suspended, when a dipole is suspended in non-uniform electric field, net force is what? First one I need to discuss about potential energy. U is equals to minus PE cos theta. This is U. So you know already for the conservative fields again. For conservative fields, F is equals to minus del U. So it's a partial differentiation. So that's what F is equals to minus del dou by dou x. Okay. So of U I cap minus dou by dou y of U, so j cap minus dou by dou z of U, it's a k cap. So this is the force, total force. Now this belonging for what? Fx. It's for Fy. This is for what you say, it's a Fz. Vectorially, so the net force is equals to F net is equals to Fx I cap plus Fy j cap plus Fz k cap, we can write it. So if the picture is given in 3-dimensionally, okay, so this is in a 3D. So for the 3D means what? X, Y and Z 3 are mentioned. So we need to take about this. Only X is mentioned. So Fx means what? Minus dou U by dou X or del U by del X. I cap is what? It shows it's a direction. Here we are discussing about electric field due to an electric dipole. So electric field, so just what? An axial line, an equatorial line, which is making an angle theta with the dipole. Okay. So for all the cases, we are going to find about electric field due to an electric dipole. Okay. So just what? First I'm talking about, I'm choosing about coordinate system. Okay. So just electric dipole is considered here. This is what? It's a minus q and plus q. Here is the center. It's what? O. Okay. So I want to find electric field at this position. Okay. So which makes an angle theta with the center. So this is what? From here, this. Now with this minus q and plus q, this is what? Let it be the point P this. Okay. So next one, I'm choosing, this is what? Regular line I'm choosing as this. It's a regular line. Okay, which is angle made with this. And next one, so this I'm taking about, it's a dotted line with a plus q, and next one it's a minus q. Yes. So here the distance is what? It's a. Next one, this one also a. Let it be, this is r1 and r2. This is r. Yes. So along with this, here is a point. This is a point. Yes. So from here, the electric field, for example, this is what? Plus q, and next one is the minus q, which is closer to the point P. Plus q affects more. Plus q affects more means electric field due to plus q, what happens? So it should be Just I'm trying to show electric field due to plus Q, it should be away. E due to plus Q. E due to minus Q, okay? Minus Q means what? Towards, like this. The resultant of these two, this is what? E minus Q. The resultant of these two is what you say, it's a vectorially if you take about, so this is what, just I'm taking as, this is electric field, it's a tangential component. Electric field E theta is a tangential component. So next one, this is, it's a electric field is taken, it's a tangential component. Next one is taken as what? Radial component. Radial component. So E theta is called tangential component. It's a tangential component. For the tangential component, E theta is equals to K. K means what? 1 by 4 pi epsilon naught. Kp sin theta by r cube. And ER is radial component. It's a radial component. So radial component ER is equals to 2kp cos theta by r cube. So E theta and next one is what? ER. So the resultant both of these two are which are making some angle theta. Okay. So if we talk about very first case, parallel to this one draw a vector. Parallel to this one draw another vector. Yes. So this will become as what? It's a ER. This one also ER. It's a E theta. This one also E theta. So what is the resultant? The resultant is, this is the resultant. What is the angle made by the resultant? Okay, so it's what? E resultant at the point P, and this makes an angle theta. It makes an angle theta. So this is what, for example, alpha I am taking this. This tan alpha is equals to angle made by resultant with the radial component would be asking. So tan alpha is equals to opposite by adjacent E theta by E r. Tan alpha is equals to, what is the E theta? E theta means what? Kp sin theta by r cube by, so then what? Next one is 2, this is what you say, ER. ER is what? 2 kp cos theta by what? R cube. R cube and R cube cancel. Kp cancels. Okay. So will become as what? It's a tan theta by 2. Tan theta by 2. So then what? Alpha is equals to tan inverse of, okay, it's a tan theta by 2 is the relation. Just what? If he's asking about the angle, we can write on this like. So next let us come to this one. What is the resultant? Means what? EP. EP is equals to under root of, so what is this? E r square plus E theta square. This is equals to under root of, ER means what? Radial component. Radial component is what? 2 kp cos theta by r cube whole square plus kp sin theta by r cube whole square. So then simplify on this. Kp, okay, kp square by r cube means what? I can write it as what? Kp by r cube outside. Next what left? 2 cos theta means under root of, we can write 4 cos square theta plus sin square theta. This is 4 cos square theta plus this is what? Sin square theta. So it would be what? This is kp by r cube times under root of 4 cos square theta means what? 3 cos square theta plus cos square theta. Cos square theta plus sin square theta is 1. So then we can write 3 cos theta. Okay. So 3 cos square theta plus 1 is your relation. Okay. This is electric field at the point, so which is making an angle theta. This is the condition. Okay. So next one. So for example, I want to talk about this. It's an axial line. Okay. On the axial line. An axial line means what? For the first one, on axial line. For axial line is theta is equals to what? Which makes this point comes down with the dipole. What is the angle made here? This is what? Theta, right? So it's a theta is equals to 0 degrees. Theta equal to 0 means what? Cos 0 is 1. Okay, so sine 0 is 0. Square root of 4 is what? 2. So this will become as what? E axial is equals to 2 kp by r cube. Okay, 2 kp by r cube. Similarly, on equatorial line, on equatorial line, theta is equals to, so 90 degrees. 90 degrees means here, which is making like this one. Sin 90 is 1, cos 90 is 0. So then what is the answer? E. So equatorial is equals to, so what is the condition? Kp by r cube. K is what? 1 by 4 pi epsilon naught. P is what? Dipole moment. It's a 2a cube. Here we are talking about electric potential due to dipole. So just I'm taking about, this is the axis. So on this electric dipole is considered. It's a minus q and plus q. This is the point. Okay, it's O. This is A as usually. So if I want to find at this position, electric dipole at this point. Okay, so the electric dipole, so this is what line joining from here, this which makes an angle theta. Okay, it makes an angle theta. Yes. So axial means what? Theta is equals to 0. Equatorial means what? Theta is equals to 90 degrees. Okay. So this is what, if you are taking about, this is R1 and R2, and potential due to total potential V, potential due to positive charge plus potential due to negative charge. Electric potential V is equals to Kp cos theta by R square is the formula. So theta is, which is making the line joining where you want to find at the point P, which is making an angle theta with the dipole, that is theta. Okay, theta is axial. So this theta is for axial. For axial, theta is equals to 0 degrees. For equatorial, so for equatorial, theta is equals to 90 degrees. Okay. So now I am talking for the first case, electric potential on axial line. At a point on the axial line, then what? Theta is equals to, what do you say? It's a theta is equals to 0 degrees. This will become as what? Kp by r square. So for next one is what? For the equatorial line. So it's what? Equatorial line. So equatorial line means what? Theta is equals to 90 degrees. So this is equals to Kp cos 90, cos 90 value 0, that you remember, by r square. What happened this? It's a 0. So what is the electric potential at a point on equatorial line is 0. So electric potential at a point on an axial line. So axial line, what is the answer? Kp by r square. So this is what? Kp by r square on axial, and this one is what? On a equatorial line. Force between electric dipoles. So electric dipoles, so just I'm taking about, there is a line. On this line I'm choosing about two dipoles. Here two dipoles are taken. This is P1, next one is P2. Here minus Q and plus Q. Here also this is minus Q and plus Q. Yes, distance of separation I'm choosing as it's a R. This is the distance of separation. So it's a minus Q plus Q. Now potential energy on second dipole, potential energy on second dipole due to first dipole due to first dipole due to first dipole is equals to u to 1 on to due to 1 on to due to 1. So now just you choose about this is what here is the point. Okay, I'm talking about the point which you are choosing here, this. But due to this one, what is the electric field is created? Due to positive charge, okay, it should be away like this. Due to negative charge, listen carefully, due to positive charge it should be away. Due to negative charge it should be towards. The resultant is what? Downwards. This is E1. Electric field is created due to first dipole on second is E1, it's a downwards. And this is the dipole, first dipole P1 is what? It is what? In upward. What is the angle between this P1 and E1? The angle is what? Theta is equals to 180 degrees. Angle between, so it's a P1 and E1 is equals to 180. So you know cos 180 value minus 1. Now I am writing interaction energy. So this is what U21 is equals to electric potential energy on second dipole due to first one. U21 is equals to, that's what actual formula, PE cos theta is the relation. So U21, 21 means what? On which you are talking to? P2 due to first one theta. U21, it's a minus, correct? U21 is equals to minus, it's a P2. E1 is what? This E1 into cos, what is this? 180 degrees. Now, my question is about what is the electric field due to this dipole at this point? This point become as what? It's a equatorial point, correct? So equatorial point means what is the electric field due to equatorial point? E1 is equals to, okay, Kp by r cube. An axial line 2Kp by r cube. So this is U21 is equals to minus P2 Kp1 by r cube. S cos 180 is minus 1. U21 is equals to minus into minus plus. So this is what? K P1 P2 by, it's a r cube. So there is the sign convention. So between these two, so what sign we have? It's a plus. So force F is equals to what is the condition? So dou U by dou X minus dou U by dou X. So this will become as what? Minus d by dx times of U is what? K P1 P2 by r cube. Okay. So this is what? Minus as it is K P1 P2 d by dx times of r to the power of minus 3. Okay. So F is equals to minus dou U by dx. So like we can write, this is what? Minus K P1 P2. So d by dx of this is what? Minus 3 okay, by what? R to the power of 4. So the answer is what? It's a 3K P1 P2 by R power 4. So for the first one is what? Potential energy, sorry, the force between the two dipoles F is equals to 3K P1 P2 by R power 4.